Hello everyone, I want to talk to you about the power chain rule. Power chain rule for derivatives. Alright, so we've already established that in order to take the derivative of a chain rule, we would have something like this. F of x equals some a value x to the bth power, and then your derivative or your slope generating machine, also called the instantaneous rate of change. You pull out your coefficient and then you focus on this part that has the x in it. So pull the power down and then subtract 1 from the power. Alright, so what would happen if we have a function raised to a power? So what if we have something like k of x equals a times f of x raised to the bth power. An example of that would be, what if we have k of x equals 7 times x squared minus 9 to the 5th power. Okay, so a number in the front, and now we have a function raised to a power. Number in the front, function raised to a power. Now this is going to act exactly the same, well not exactly the same, will be similar to what we see with the power rule, in that at the end of the day we have to worry about the something raised to a power, right here, something raised to a power. Alright, so if I were to read this out loud, this would be 7 times x squared minus 9 times x squared minus 9 times x squared minus 9 times x squared minus 9. So as you can get the point, you're basically multiplying out the x squared minus 9 5 times. So I have to deal with the fact that I have something to the 5th power, just like here we have to deal with the fact that you have something raised to a power. So the approach is going to be very similar when you take the derivative. Okay, so what I typically tell my students is I say, this is going to be my block, right? It's a block of information. So I'm going to pull out my coefficient and I'm going to take the derivative around this block of information. So here we go. Pull the b down, there's your block, raised to the b minus 1, right? So now this derivative looks very similar to what we see here. Okay, there is a big difference because I make this a block or a brick. I cannot change this the first time around, so this will be f of x, but then I have to go back in and clean up my derivative by taking the derivative of the inside piece, right? So the block has to disintegrate. Okay, so let me be clear that you are going to pull out your coefficient, pull down your power, 1 less power, inside stays the same. And then in order to deal with the fact that you didn't take the derivative of this first one the first time around, you have to disintegrate the brick and multiply by the derivative of it. So let's try it here. We have k prime of x. Again, your derivative or your slope generating machine. Let's pull the 7 out. Alright, and then let's have it on this piece right here. Pull the 5 down. 5 minus 1. The inside stays the same. This is my brick on my block. So what I have there goes right there. X squared minus 9. Okay, so you're basically taking the derivative around the x squared minus 9. And then you clean up your derivative by taking the derivative of that piece that you didn't touch the first time around. 2x minus 0. Like that. Okay, so then your derivative, k prime of x, equals 7 times 5 times x squared minus 9 to the 4th power times 2x. Let me put squared off brackets there. Alright, now the beautiful thing about this is that you should be able to simplify it even further. You want to combine like powered items. The 7 is raised to the 1st power. This 2x as a chunk also raised to the 1st power. So I can combine those. And this 5 is also raised to the 1st power. So then k prime of x equals, let's see, 7 times 5 is 35, times 2x is 70x. And then I have x squared minus 9, which is raised to the 4th power, which I can't touch that. Okay, again, all of the other pieces, if it makes you feel comfortable, raise this to the 1st power. All the other pieces were raised to the 1st power, and then the x squared minus 9 was raised to the 4th. All right, let's try that again. So what would happen if we had g of x equals 9 over 4 times 3x to the 5th power minus 13x. And let's make that squared. All right, so the first thing you want to do is rewrite this. So as I said, weave the numbers together, 9/4. And then I'm going to make this 3x to the 5th minus 13x to the -2, right? So I'm bringing this chunk of information that was in the denominator up by negating the power. So we're ready. G prime of x, according to the rule, you pull the 9/4 out. And then we need to take the derivative of this that's being raised to the -2 power. Okay, so -2. Here's my brick. To the -2 minus 1, which is -3. Okay, so again, I'm taking the derivative around this piece that you see here. Right, it's called a chain rule because it's a process. All right. So in here we have 3x to the 5th minus 13x. And then finally, I'm going to clean this up by taking the derivative of this piece that I didn't touch the first time around, which is going to be 15x to the 4th power minus 13. Like that. All right, so of course you can combine certain things. This 9/4 here, this is raised to the 1st power. The -2 also raised to the 1st power. This 3x to the 5th minus 13x is raised to the -3, so I won't be combining those with those other two. And then the 15x to the 4th minus 13 is raised to the 1st power. All right, so let me show you how that appears. G prime of x, our instantaneous rate of change. 9/4. Let's multiply that by -2. And I'm going to bring this one to the front also. 15x to the 4th minus 13. And then I'm going to rewrite this one because it makes me uncomfortable to have that -3 power. So 1 over 3x to the 5th minus 13x. All of that is being cubed. All right, so in order to combine these, I'm going to make this over 1 and make this one over 1 also. So I have to multiply straight across. So then g prime of x then equals -18 over 4, 15x to the 4th minus 13 over 1 times 1 over 3x to the 5th minus 13x, that quantity cubed. I guess I could put some brackets there too. Okay, so I may come back and clean that up further. The numbers are just a little large for me. But let me show you another example. So then, what would happen if you had, if they say y equals 4, the 8th root of 10 plus 6x squared. Let's make that cubed. All right, so then the rewrite on this is going to be 4 times 10 plus 6x squared. Notice the 8 is going to come around, so this is to the 3/8 power. Okay, so here we go. Another way of saying that they want you to take the derivative, they could say y prime, or they might say dy dx. Basically this says take the derivative of y, paying attention to the x's, right? So I'm just trying to show you different notation that you might see in your book. So here we go, pull the 4 out, 3/8, and then we have 10 plus 6x squared. This is your brick. There it is. You cannot change it the first time around. To the 3/8 minus 1 is negative 5/8. And then you're going to take the derivative of the inside piece, which is 12x. All right, so that's all of that. Let me run through that again. There's a 4. You pulled that out. The 3/8 is from this power. The inside can't change the first time around, but you have subtracted 1 from the power, and then you go back in, you take the derivative of the inside. So let's see what we can combine. We combine this 4, which is the first power, combine the 3/8 to the first power, and the 12x. So then your y prime, or your dy dx, equals 4/1 times 3/8 times 12x over 1. Times 1 over the 8th root of 10 plus 6x squared to the 5th power. Okay, so these two pieces are the same. Okay, please go back over the other videos to see why they are the same. The negative drops the chunk to the denominator, and then I'm dealing with a power of 5/8. All right, so 4 times 3 times 12. This is 12 times 12. This is 144/8. Now, since this is one big fraction, you can just multiply all of those together. So 4 times 3 times 12x times 1 is 144x. And then the denominator, I have 8. And we also have an 8th root, of 10 plus 6x squared to the 5th power. Okay, so of course you can simplify that even further by getting rid of the common numbers in 144 and 8. And if you do that, you'll get 18x in the numerator, and in the denominator, you get the 8th root of 10 plus 6x squared to the 5th power.